My name is Richard Widdess. I'm Professor Emeritus of Musicology at SOAS, University of London, that is School of Oriental and African Studies. For some years I've worked off and on with Martin on aspects of Indian music that perhaps lend themselves to a mathematical approach. There is one exhibit in the exhibition that derives from our work. So I thought I'd say just a few words about what you might consider some generative processes or maybe algorithmic procedures that one finds in Indian musical theory and to some extent in practice. And I'll briefly talk about three examples. Recursive elaboration, which is what the example in the exhibition addresses, and then also permutation of scale degrees and permutation of scale structure. Just to start with recursive elaboration, the example in the exhibition, which you may have seen, shows how in performing an alap, a free tempo exposition of a raga, the musician bases each phrase on the one before. Each phrase can generate the next phrase by inserting something new, usually in the middle of the previous phrase. And so the improvisation expands in a very organic manner. And this goes back in theoretical sources to a famous treatise of the 13th century, the Sangita Ratnakara of Generative, who describes how to perform this kind of improvisation. He says in 4 sections. But you start with a small phrase in the lower part of the octave, a phrase that is distinctive of the raga. And then, as he says, in the remaining 3 sections, one should perform the first section again, but ascending to successively higher pitches, culminating at the octave, or the upper octave of the tonic. So as our example in the exhibition shows, this is still basically the process that is used today, and one could represent that in various different ways. This is a sort of map of the syntactical structure of a similar alap, basically showing that, so for example, if you have the 3, pitch 3 of the scale, you can prolong that, and then you can insert a 4 between the 2 3s, and that in turn can be prolonged. You can insert a 5 between the 2 4s. You can prepare the 5 from a 6. The 6 can be prolonged and the 7 inserted, and so on, as you work your way gradually up the middle octave. The second example, permutating scale degrees, this is a technique known as Kandameru, a mountain of segments. And the idea is that you take a succession of scale segments from 1 to 7 notes in ascending order. For each segment, you reverse it so that you get the descending version of the same segment, and in between you insert all the possible permutations of those pitches. So for 2 notes it's very simple, you just reverse the 2 notes. For 3 notes you do the same but put 3 at the end, and then you put 2 at the end and rotate the 1 and 3, and then you put 1 at the end and rotate the 2 and 3. So the final permutation, 3, 2, 1, is the reverse of the one that you started with. This is fully explained for the first time in that same 13th century treatise of Generative. Going on, of course, the process just replicates itself. You go through all the permutations of 3 notes with 4 at the end, and then you put 3 and 2 and 1 at the end, and so on. So the total number of permutations of all the scale segments from 1 to 7 notes is 5,040. And interestingly, this total is also apparently well known to English church bell ringers, but they arrive at that total in a different way. Now, of course, this method is not exactly a very musical method. It's a purely mathematical method. If one were to sing all these permutations, it would not constitute a mode, a raga. It would contravene the rules of any particular raga. But some musicians do practice this kandameru technique because they say that it helps them to achieve a certain facility in improvisation. And sometimes in performance, they will do something similar to this mathematical process, but at the same time respecting the rules of the raga that they're singing. For example, this particular singer, Ustad Abdul Wahid Khan, was famous back in the 40s and 50s of the last century for doing this kind of improvisation, kind of semi-mathematical improvisation. And the third example I'd like to take, permutating scale structure. This is a feature of the South Indian scale system known as the Melakarta scale system for classifying ragas. This goes back to the 16th century when the theorist Ramamatya proposed a new explanation of the structure of the scale as consisting of 12 more or less equal semitones. And he proposed that the degrees of a heptatonic scale could be allocated in a number of ways to these semitones. So the first degree is always on the first semitone, but the second degree could be on either the second, third, or fourth semitone position. The third degree could be on either the third, fourth, or fifth position. So the positions of the second and third degrees overlap. So obviously, if you have the second degree here on the second semitone, then you could have the third degree on the third or fourth or fifth semitone. So you might start with two consecutive semitone intervals here. But if the second degree is here on the third semitone, then obviously the third degree can only be on the fourth or fifth. And if the second degree is on the fourth semitone, then the third degree can only be on the fifth semitone. And so on, similarly in the upper part of the octave. The fourth degree has two positions, the perfect fourth and augmented fourth. So if you start the scale on pitch C, then these are the pitches that are available. So in the following century, a theorist called Venkatamaki realized that you could generate many more scales from this system than were actually used in practice at the time. Something like 19 or 20 of the possible scales were in practical use, but Venkatamaki realized that you could actually get 72 scales out of this system. And the way you do it is that you start with one version of the lower tetrachord and link it with all the possible versions of the upper tetrachord, cycling through the different positions of the sixth and seventh degrees. And then you go on to the next version of the lower tetrachord and associate that with all the possible versions of the upper tetrachord, and so on until you've used up all the possible versions of the lower tetrachord, giving you 36 scales. You then have another set of 36 scales by changing the fourth from the sixth semitone to the seventh semitone. So you sharpen the fourth and go through the whole process again, and you get your second set of 36, total 72. So although many of these scales were purely theoretical in the 17th century, in the 18th and early 19th centuries, musicians explored the novel scales that this system produced and created ragas in some of these, well, ultimately all of the scales of the 72. So all the 72 scales are now in practical use. They purely kind of mathematical procedure, what originally has stimulated creativity and artistry. And curiously, this same system has had influence on music in Europe. I'm indebted to my colleague Peter Asimov at the University of Cambridge for explaining this to me, how in the late 19th and early 20th centuries, a number of composers in Europe experimented with using scales from the Mela Carta system, both Anglophone and especially Francophone composers. And the reason that the French composers were particularly interested was because they saw a complete transcription of the 72 scales set out here in the Encyclopédie de la Musique of Albert Lavignac, published in 1913. So this was a ready-made source for their experimentation. It occurs in a very large article by Joanny Rosset, who is a Sanskritist, on the music of India. So there's a direct line of transmission from India to Europe at this time. And Peter Asimov has written that for European composers, perhaps the lasting legacy of the Mela Cartas was not just in the specific collection of scales, but in the theoretical notion of a generative system of synthesizing novel modes, such as, most famously, Olivier Messiaen's modes of limited transposition, which, though distinct from the heptatonic Mela Cartas, share the scheme's rationalist and permutational approach. And I can't help noticing that although, as Peter Asimov says, Messiaen's modes are different from the Mela Cartas, at least one of them, the fourth mode of limited transposition, begins very much in the sort of structure that you get in the Mela Carta system. That very first group is based on this same tetrachord, C, D flat, E double flat, F. So I suspect that Messiaen was aware of and influenced by the Mela Carta system. So perhaps some of the topics that we're talking about today have been stimulated a century ago by an encounter, a cross-cultural encounter between India and Europe. Thank you very much.
Thanks for the nice talk. If you can go back to the slide with the 72 things.
Mm-hmm. This one or further back?
The previous one. This one, yeah.
Yeah.
So I understood how you count the 72, and it's either F or F sharp.
Yes.
If I look at the top line, and the way you explained it, it looks like it's not an or condition. I don't see how you have encoded the F or F sharp. It looks like F and F sharp.
On the top line here.
Yes.
Oh, sorry. here. Yes, well, this is simply the nomenclature, the pitch nomenclature, going back to Rama Matya in the 16th century. These are all alternative positions of 2, of 3, of 4, 6, and 7.
Yeah, here in this version I see it. Yeah, okay. Yeah, thanks.
I found it very interesting that in this theory we have chromatic steps, but is it meant in the sense of equal chromaticism as we know it in Western music, or is it rather much more rich when it comes to the exact frequency position of these 12 positions?
Okay. Yeah, the way the semitone positions are defined in relation to the frets of a vina, plucked stringed instrument, and this is set out by Rama Matya. I'm not an expert in precise interval ratios and such like. But I understand that his fret positions are very close to equal temperament. They're not exactly equal, but very close. Yes.
Thank you.
Hello, thank you very much for your speech. I was wondering how the master assure the transmission to the student of that very thorough mathematical-based logic, and what is the role of the instrument in that transmission?
Well, it's certainly not mathematical in terms of the method of transmission of the music. I'm looking at written theoretical sources in Sanskrit, the classical language. And most musicians do not read Sanskrit theory and would not consider that was worth doing at all. For them, oral transmission is the only valid kind of instruction. And that involves example and imitation, often with very little verbal communication of any kind. So the practical artistry is transmitted in that way, and very little attention is paid by most performers to any kind of theoretical background.
So the Indian system of the scale construction that you showed is remarkably similar to the European system, especially going back to ancient Greece. Could you elaborate on this remarkable similarity? Like the notion of having 7 tones, the scale degree system, the alteration of scale degrees is all extremely similar.
Mm-hmm. I can't authoritatively speak about the European systems, but this system that originated in the 16th century replaced an earlier scale system which divided the octave into 22 microtonal degrees and then disposed the 7 degrees of heptatonic scales in relation to that grid of 22. And by the 16th century, and probably in practice very much earlier, that system had become quite divorced from musical practice. So something more practical was needed in the 16th century, and this is it. But even today, if you ask an Indian musician how many degrees there are in the octave, they're quite likely to say 22, because they're referring back to the very prestigious earlier sources going back to around about 500 AD that describe the scale in those terms. I think in 500 AD that probably was how the scale was constructed, but I don't think that it continued very much beyond that.
Thank you very much.